tap both methods of solving these kind of problems. So remember that what you do is you set up a ratio where you have the rate, in this case, of experiment 2, you always put the bigger one on top, divided by the rate in experiment 3. And we're going to set that equal to the concentration of B, so the concentration of B in experiment 2, and divide that by the concentration of B in experiment 3, okay? And we're going to raise that to some power y. All right? So now we can just put the numbers in. So the rate in experiment 2 was 1.01 times 10 to the minus 4, okay? And the rate in experiment 3 was 2.54 times 10 to the minus 5, and that equals the concentration of B in experiment 2, which is 0.3, so 0.300, divided by the concentration of B in experiment 3, which is 0.150, okay, and that's raised to the sum power of y. Okay, so now we can just crunch these numbers a little bit, plug them into our calculator. So clear that. Okay, so I'll bring it over here so maybe you can see it. Or actually, let me kind of slide it this way so you can see it maybe a little bit better. Okay, so 1.01 exponent minus 4, and divide that by 2.54 exponent minus 5. So hit that. So that's 3.98. Let's round to the hundredths place. Okay, and that equals, so clear that, 0.3 divided by 0.15 equals 2 raised to some power y. Okay, so now let's go back and look at this. So this is, right, that is about 4. So let's just round that to 4. So what exponent do I need to put on 2 to make it a 4? So that means that y must equal 2, because 2 squared is equal to 4. Now the other way to think about this is that I could just take the natural log of both sides and get the same answer, all right? But because that's not necessary in this simple case, why do that? All right, so now I have the exponents, and I have all the numbers that I need. So the actual rate law then, if I were to write the rate law, now that I know the exponents, is equal to the rate constant times the concentration of A raised to the power of 1. I figured out that it was first order. Okay, and I already figured out that B, because y is equal to 2, is second order. Okay, so times the concentration of B squared. Okay, so now to answer the question, remember what the question tells us to do. It says calculate the value of the rate constant. So I need to calculate K. That's what I'm looking for. And this is the way that you do that. Now that I have the rate law, all of these experiments have to obey the rate law. So I can plug the numbers in, I can pick an experiment, plug the numbers in, rearrange, and solve for the value of the rate constant. So since it's closest to the rate law, let's just go ahead and use the values in experiment 3. So the rate in experiment 3 is 2.54 times 10 to the minus 5, and that equals the rate constant times the concentration of A in experiment 3, which is 0.450, and that's just raised to the power of 1, multiplied by concentration of B, which is 0.150 squared. Okay, that's a 0. Okay, so then you just isolate the rate constant, so you got 2.54 times 10 to the minus 5, and you divide that by 0.450 times 0.150 quantity squared. Okay, so then you just do the math. Okay, so let's do the math. Okay, so clear that. All right, so 2.54 exponent minus 5, divide that by 0.45, hit enter. Now we're going to divide that by 0.15 quantity squared, we hit enter, and so you get 0.0025. Now this is a third order reaction, okay, and so the units here are going to be inverse seconds and inverse molarity squared, so to the minus 2, okay. And there you go.